Hello, pre-calculus student. This video is for chapter 6.1, graphs of sine and cosine functions. You might say, Ms. Chan, we already know the graph. The graph is a unit circle, but actually that is not true. When we see the unit circle, we thought that, oh, that's sine and cosine, but actually it's not. Sine and cosine are the points on the unit circle, but the points belong to the unit circle. We actually do not know how sine and cosine increase or decrease. Let's look at the unit circle one more time. Okay, so this is the unit circle. So we know x value is the cosine function, y value is the sine function, right? So, and then angle is the input. So if my input is 0, my cosine would be 1. And then my input 30, when I have more, my angle is more. My cosine is root 3 over 2, a little lower. And then when my input is 45, my cosine is root 2 over 2, and then lower and lower until when my input is 90 degree or pi over 2, my cosine is 0. You see how these points are just points of the unit circle, but not the graph of sine. Sine actually is decreasing. It starts off at 1 and then gradually becomes 0. So, and then at 120 degree, 135 to 180, it actually decreased more. It decreased to negative, finally to -1. So we kind of feel the way that the cosine graph is moving, but we don't have a graph for it. So in this particular um, chapter, we'll look at how the sine value change with respect to the input. Now, the input actually is the angle. Okay, so when I say a function of y equal to sine x, y is the sine function value and x is the input angle. So we are graphing the angle and the sine value. So we can actually build a table. So we'll do a cosine first because we were looking at cosine. At x, which is 0, then y equal to cosine is the x value. It was 1, right? And then at 30 degree, which is pi over 6, we only do radian now when we graph. And this would be root 3 over 2. Root 3 over 2 is actually what? In terms of values, if we put in the calculator, just approximately what is root 3 over 2? We would do second root 3 and then divided by 2 is 0.866 actually, 0.866. So you can see that it's decreasing, 0.866, and then it decrease up to, we know at pi over 2 becomes 0. Then gradually at 3 pi over 2, it becomes at pi, it becomes -1. It gradually get lower and lower. Go to pi, it is -1. And then the cycle actually change or improve so that when it's going back up and at 3 pi over 2, it go back to 0. And then at 2 pi, it go back to 1. So if I graph this x, this is the input, the angle, theta, or x, we call it x. X doesn't mean the x value in the unit circle, it's just the input. So I have my x from 0 to pi, and then to 2 pi. You can see that it's a cycle. In the beginning is 1, and then it go to 0 at pi over 2, and then it go to pi like that. Gradually at 3 pi over 2, it go back to 0, and at 2 pi it go back to 1. So that's how we understand the cosine graph. The characteristic of a cosine graph is one period is 2 pi, meaning after 2 pi, I would go another cycle of like a big V, right? But actually is, and then on this side, they go on forever because we know angle goes on forever and this goes on forever. We usually graph one cycle, but we can have. And the range of y is 1 to -1, right? They go on forever. They don't drop down below -1 or go above 1. X can be any real number. So if you have long enough the x-axis, you can have this cosine function going up and down, up and down. So the domain is negative infinity to infinity. Cosine start from 1, then drop to 0 at pi over 2. The midline is y equal to 0. And there is another word called amplitude. Amplitude is how far away the highest point is from the midline. We can see that it is 1, right? How far away it is from. That means when the wave fluctuate, how far away are they from the midline? The amplitude is 1. It's 1 and 1 top and bottom. So that's cosine graph. Let's look at sine graph. We have to look at the unit circle again. So if my input is the angle and I look at sine is the y value. So in the beginning, sine is 0. Gradually improve, gradually become more. This is root 2 over 2 is 0.7, I think. And then root 3 over 2 is 0.8. And then gradually sine at 90 degrees, sine is 1, the highest. And then it dropped back to 0. And then it dropped to negative 1 at pi, right? So it's increased very high, and then no, not negative 1, dropped to 0, and then it drop to negative 1 because the y value is negative 1, and then go back to 0. So we can do the same thing as before. We would actually track the value of how the sine value change with respect to the input angle. We know in the beginning when you have 0, sine x is still 0. And then when you have pi over 6, sine is 1/2. Gradually at pi over 2, it go up to 1. But at pi, it go back to 0. At 3 pi over 2, it go actually down to negative 1. And at 2 pi, it go back to 0. So if I graph the input from 0 to 2 pi and then 2 pi, the functions like go to the top at pi over 2. Okay, so this is 1. Go to 1 and then drop down at pi, go back to 0. But it doesn't go up again at pi. After pi, it go down to negative 1 and then go back to 0. So this is 3 pi over 2 and this is pi over 2. So this is how the sine curve look like. So of course you go on forever. It's a periodic function. It would go on forever. But one basic cycle is, this is the basic cycle. The input is not 1, 2, 3, 4. The input is angle. And for angle, one complete circles, the angles are from 0 to 2 pi. Okay, from 0 to 2 pi. So you have 0 degree, go, and this is 2 pi. So in the x-axis, you don't see 1, 2, 3, 4. The y-axis, you see 1 and negative 1. The x-axis, typically, you will see 0 to 2 pi. That means one cycle, one circle. Okay, because the unit circle is 0 to 2 pi, is not 0 to 1. The characteristic of the sine curve is such that it repeats after 2 pi. So we say period of a basic cycle is 2 pi period. We call it a period. Okay. Y ranges from negative 1 to 1. X can be any number. It's negative infinity to infinity. Sine x start from 0 and then peak at pi over 2 to 1, right? To 1. So it's very similar to cosine. Cosine peak at the beginning and then drop to negative 1. But sine start from 0, drop back to 0 after hitting the first local maximum and then drop to a local minimum and go back. Okay, the midline is y equal to 0. Again, amplitude is 1. How far away it is from the midline is 1. So summary of the sine curve. So this is actually, we graph it ourselves this way, but you can think of it as a wave that goes on infinity. Sine curve is basic one is here to here, stop at 2 pi. But the cosine is a big V, the middle one, right? But it goes on forever. So they look similar, but it's kind of like a little shift. Sine curves had a 0, 0 point, but cosine curve has 0, 1 point. Because of the particular shape, we actually can say sine is an odd function. Odd function is when it is symmetrical over 180 rotation, whereas cosine curve is a even function, is symmetrical on both sides. When a function is symmetrical on both sides, that is an even function, symmetrical about the y-axis. So in the next video, we'll talk about how to graph not just y equal to sine x or y equal to cosine x, but a sine bx or a cosine bx, where you would have some number in front of the function and some number in front of x. What would it look like?